What I'm going to do here is create a normal curve that has a mean of 2000 and a standard deviation of 500. So we're going to start off with 4 standard deviations above the mean, and we'll go up by or down by 0.1 every time. So what I can do is copy down this to go down to -4 standard deviations below the mean. And so now our value. So what we're going to do is 4 standard deviations above the mean. Well, if the mean is 2000, 4 standard deviations above the mean will be 4 times 500 plus the 2000, so it's 4000. So I'm going to create a formula here. So this will be equals, and it'll be A2, then times the standard deviation. And we're going to want to create a global reference for this, so we'll put in a $sign. And then it'll be plus our $2,000, or plus our mean of 2,000. So there we go. And if we copy this down, it should be, and it didn't work because we didn't have our global reference for the mean. So I have to put a $sign. And now when we copy it down, it should work out. So when we get to a value, 2000 should be a standard deviation of 0. And there we go. And we end up with this negative 4.8 times 10 to the negative 12, which is a very small number. It's just because of rounding in Excel. So now what I'm going to do is, got our values. We know the number of standard deviations, so this matches up because down here, 0 standard deviations from the mean is going to be the mean. So mean of 2000. So our formula is working okay. So what I'm going to do now is put in a formula which is norm distribution. And we've got to put in our value, which is in cell B2, our mean, which is in cell G1, and again, oops, there we go. And I want to use a global reference there. And our standard deviation, which is in I1. And our cumulative, we'll do false and true, and you can see the difference between them. So the false is what we want right now, because it's just going to calculate the probability that a value in this distribution has, with a mean of 2000 and a standard deviation of 4, what the probability of having a value of 4000 exactly. And so it's going to be a very small number. So I'm going to put in false. And then close the brackets. And we end up with this very small number. And so when I copy this down, and you can see that the probability of having exactly 2000 as a value is a very low number, but keep in mind, it was 2001, 2002, 2003, all those are around there. So when we, I'm going to now graph this information, and you're going to see the normal curve. So I'm going to go insert, scatter, and we'll select the smooth, scattered with smooth lines, and there's our probability, there's our normal curve. And so and there we go. Okay, so now if we just see what happens when we change the standard deviation, make it smaller, so put it down to 100, you can see that the curve becomes very narrow because there's a lower standard deviation. And if we undo that and change the mean, it'll shift it up. Okay, and so I'll change this back to 2000. And so there's our normal curve. Now, going back over here, I'm going to do the same formula that we did before. So this is going to be equals norm distribution and again we're going to put in cell B2 the mean the standard deviation and I'm using the global reference again. And this time I'm going to say true. Okay, and when I copy this down, okay, this allows us, so here if we go up to the median, which is our mean value, according to our normal distribution, we expect 50% of the data to be at or below this value of 2000. All right, and so that one standard deviation, that's pretty close to our 16%, because remember that 34% of the data is between the mean and one standard deviation below the mean. And if I cursor up, okay, we have 84% of the data is below one standard deviation of the mean or below a value of 2500. Okay, so we'll take a look at this. And so that when you get up to standard deviation of 4, if you have a value of 4000, we expect virtually all the data to be below that value of 4000. Okay, so you should see how this matches up with what you know about the normal curve. And I can actually show that the distribution here. So if I take a formula, so I'm going to go equals, so that's one standard deviation above the mean, and I'm going to subtract the value for one standard deviation below the mean, and we find that this is 0.68. If I change that to a percent, it's 68%. So 68% of our data is between one standard deviation above the mean and one standard deviation below the mean.